Hey guys, welcome back to another episode of solving Namaste SQL problems. I have already made 2 videos on this, so if you guys have not watched that, I would request you to go ahead and watch because the problems that I've solved here is absolutely amazing. I can at least give you that. So please go ahead, try to solve those problems. You don't necessarily have to see my solution. Please come up with your own solution and then we can, compare and contrast. But okay, so this is the third video. We are only left with 3 problems. Majority of like today's problems are known as like extra hard or hard problems. So let's see how we can solve those and how much time do we take to solve those, because time is of utmost importance. Mark my words. All right, so without further ado, let's move ahead and start solving. Okay, so key out of stock events. This is an extreme hard problem. Okay, let's see. You are working with a large data set of out of stock events for products across multiple marketplaces. Achha, okay. Each record in the data set represents an out of stock event for a specific product. Each record. Let me see. Select star from detailed OOS events. Okay. Detailed OS events, right? Oh, sorry. So master ID, each record in the dataset represents an out of stock event for a specific product. Okay, my laptop is slow for some reason. Okay, master ID, marketplace ID, and OOS date. This is the master ID is a product ID. Each record in the dataset represents an OOS event for a specific product. Product plus master ID. Okay. Specific marketplace on a specific date. The combination of these is always unique. Your task is to identify key OOS event dates. Is always unique. Yeah, of course it has to be. But P04 became out of stock on 7.3. It again became out of stock on 7.4. It became out of stock on 6.30. 7.1. This is 1 year later. Okay, got it. Okay, fine. Is always your task is to identify key out of stock event dates for each product and marketplace combination. What is key out of stock event dates? Steps to identify key out of stock events. Identify the earliest out of stock event for each. Master ID, marketplace ID. Okay, master ID, marketplace ID is the first event. So this one, 7.3. Yeah. For P04G and 13, this is the first ID. Recursively find the next out of stock event that occurs at least 7 days after the previous event. Okay. Continue this process until no more OOS events meet the condition. So what do I need? Expected output is 7.3. For next is 6.30. Oh, 1 year later, because 7, that's the first one that we have. Okay. Then 7.7. 7.14, 7.21. Okay, so I think the problem is clear. Okay, so let's write down the steps now. Okay. So what I'm thinking first, let's give a rank to each of the rows, right? First, we have to do that. Recursion or not recursion, we have to keep the first one. So there's only one way to do that. We have to rank it. And then finally, let's map the table with itself, of course. Map table with itself by considering the OS date having 7 days of difference with each other, right? So that's fine. Marketplace ID, OS date, and then finally we will take the least ranked one that will come always at the top, and then anything at 7-day gap. Oh, sorry, this is output. Yeah. Anything at 7-day gap will basically come up. 1 second. Okay, so this is the steps. These are the steps. Map with the table with itself by okay, so these are the steps. If you look at the data, so we can give rank to each of the rows. Yes, we will do that, and then we will map with the next 7 days, 7 days the way. We have to use recursion here, is what I think. Okay, let's go ahead. We will write down the steps as we go. And then finally, basically, we will take only consider the dates where out of stock date is greater than 7 days from the previous one. Right? Okay, so again, I don't think everything will be clear just from the steps, writing down the steps, but we have to actually solve the problem. Let's go ahead. So with, let's say, ranked as select star, comma, row number. You can take rank as well here, doesn't matter because everything is unique, but I think since this is working as an index, row number makes more sense for me. Feel free to choose your own. Then I will do partition by master ID and marketplace ID. Ordered by OS date, right? As let's say RN from detailed OOS events. This is the exact number of columns that we need. And finally, what will we do? Let's say, let's do a recursive mapping. So select, let's say we can take only the first row number because in recursion, what you have to do, especially like in any language, what we do, we try to find out the first row or the first data point, right? And then we keep on moving from there. We calculate the next one, next values or rows forward. So first in here as well in SQL also, since we work with rows, not singular values, so we have to select the first row. So let's select, let's say everything. Oh, yeah. In recursion, we have to do union. So we have to specify the rows separately. We cannot just mention a star. So master ID, marketplace ID, let's say OOS date, right? And it helps in recursion if you have a some kind of a flag because we're taking counter, right? So let's take one as counter something, right? From ranked union all. Oh, where Rn equals to 1. So that's the first row that we have selected. For each master ID, marketplace ID, whatever is the first OS date, we will be taking that. That's our first row at that level. Then we are unioning it with, let's say, exactly same thing. Counter we will change, but I will come to that. So counter would be 7 days, right? Can I make it a +1? Usually we do whenever we are doing, we are actually creating a counter, we are creating date after date after date or ranks after rank. In recursion, we do 1 + 1 or we'll basically do counter +1. Here, don't think that's an option, but let me try it. Okay, from ranked or let's say, do I need ranked? Yeah, I need. Join recursive mapping because this is where recursion will be happening actually RM, let's say, on r dot master id rm dot master id and r dot let's say marketplace id rm dot marketplace id and r dot okay. Now rm is already fixed because this is the first row. What we are trying to fix now, we are trying to get the next eventual next rows in the process. So that will be r dot oos date should be greater than equals to date at rm sorry day comma 7 comma rm.os date. So that's what the condition is mainly. Then finally we will take only those where counter is minimum basically. So one as counter is fine. We will take one and then we will take the minimum ones. Here, okay, let's go ahead and run this and then we will be able to just understand better. Incorrect syntax near RM. Not RM. This is R. And. Okay. And. What happened here? Yeah. Oh, okay. R dot. R dot. R dot. Okay. Let's try. Okay. So we have P04. Okay. If I do order by master ID, marketplace ID. OS date. Then we'll be able to understand how this came out. And then we will do further uh, transformations on top of this. Okay, so 7, 3, then 2, 2 again. So that's not needed. Again, we need 3. So see, we need each counter and 1. The top, we need the minimum date at each counter, basically, right? So master ID, marketplace ID, counter level, we need the minimum date, and that's it. That's all. I think, right? 7, 7, 7, 14, if you see. 1 second. Okay, 1 second. OS date and counter. If you do like this, we need the minimum. And that's it, we're done. 2, 2, 2. Okay. Counter and OS date. Okay, that would have made more sense. This way, it's easier to visit and understand. Okay, now see. Okay, so 7, 3 is 1. 2, this is the minimum one that we should be taking. Then 2, let go of 2. 3, 7, 7. Then go to 4 directly. Yeah, 4 and then 7, 14. So get the idea? So what will we have to do? We will do select master ID marketplace counter. We can take a min mapping as comma min of OOS date from recursive mapping group by master ID, marketplace ID, and counter. That's it. And then finally, we'll need select OS date as OS date. So master ID, marketplace ID, and OS date. Min mapping. So this should give you the output. Okay, let's see. 7, 3, 6, 30, 7, 7. Okay, 1 second. 7, 7. Finally, P06 has too many. Yeah, that has about one. Yeah, has about some. Yeah, which is fine. I think 415. Think this should work pretty fine. Let's see. Correct. Okay, so let's go through the problem once again because I believe that this is a very good problem and it's a quite hard problem as well. So what did I do here? I just took row number first, right? So I created ranks basically for each of the rows or records that we had. Finally, what I did in recursion, what happens? We usually take the first row out at each level. First, decide your level. And this is the level at which I'm going to take the final result, and then let's take the first initial starting record in here, and that's what happened. That's what I did at master ID, marketplace ID, and OOS date. Sorry, master ID and marketplace ID level. I took the first rank, that is OOS date, because I have already created the rank earlier, and then I'm only considering that rank one at these two levels, right? So to understand the level, you have to focus on the first CT here. Hopefully that's clear. And these are the three columns that we are taking. And counter is nothing but, so specifically, let's say if you are more savvy with Python or C++ or like, proper coding languages there, since we already take iterators or variables, we do not have to keep a counter separately. But in SQL, if you see, we do not have necessarily a looping system, right? So if you are creating something like a recursive format, you have to keep a counter, and that's what we do. We try to keep a counter, usually starting from 1, can be some other number based on your use case, but usually we do it from 1, and then we keep on increasing that at each of the like next step or recursion level that's happening. So what did I do here? Then immediately at like what recursion in SQL tells us to do, took the ranked table which I created earlier, then I'm joining it with the recursive CT in this one. In some of the SQL platforms, you have to mention as recursive space CT. In here, you can just mention a CT name, and automatically, if you call it, SQL will be able to understand that you're calling a recursive CT. You do not have to specify it otherwise, but this is just info. Good to know. Now what am I doing? I'm taking ranked function and I'm mapping it with the recursive CT, right? What is the recursive CT? Again, reminding, this is the first rank. Now I did match it using master ID, marketplace ID, because I need the same level, same master ID, marketplace ID should be same, and my ranked date should be greater than equals to at least 7 days of the starting rank date, right? So starting date was something 7/3 or something, whatever it might be in your table. So I am mapping 7/3 with all the next days which are at a gap of more 7 days. So that happened, and I'm taking that as counter. So why am I taking the counter, and how is the counter a help here? Because let's say 7/3 is getting mapped to 6/30, 7/7 next year, so on and so forth. We need the minimum, right? We need the minimum. We need 6/30 because that's the closest one that gets mapped, and that is what is the requirement of our problem as well. So that's what we are doing. Finally, I am taking the min mapping. Why min mapping? Because master ID, marketplace, and counter level. Why counter? Because each counter, see what happened. If you recall, 1 second, I have to run this again. Okay, so I ran the query again, the recursive mapping. So basically what's happening here, just to give you a glimpse, at master ID and marketplace ID level. So the first OS date is always having counter 1, right? Because that's the starting condition of the recursion. And then after that, so 6/30 gets counted to be 2. And then immediately next one, since it's a recursive join, 7/1 won't be getting counted 2, but rather 7/7 would be getting the next counter, which is counter 3. And immediately, let's say if you go to counter number 4, That will be starting from the next 7 days. That will be 714, right? So that's what is happening. So now if you do a, finally the query that we had, we are good. And let's submit and move to the next topic. I think this was done, right? Yeah. Let's see, evaluate. Cool. All right. So the extreme hard problem done. Little kudos and little clap to ourselves. And let's move ahead. Employee's current salary. Okay, so in your organization, each employee has a fixed joining salary recorded at the time they start. Over time, employees may receive one or more promotions, each offering a certain percentage increase to their current salary. Okay, you're given two data sets. Employees contains each employee's name and joining salary. Promotions lists all promotions that have occurred, including the promotion date and the percent increase granted during that promotion. Contains each employee's name and joining salary, right? Okay, perfect. Now, promotions lists all promotions that have occurred, including the promotion date and the percent increase during that promotion. Employee ID. Okay, makes sense. Your task is to write a SQL query to compute the current salary of every employee by applying each of their promotions increased round to two decimal places. The employee has no promotion, current salary remains equal to the joining salary. Okay. So ID, name, joining salary, and promotion increase, etc., etc. So final output that's needed, I think, employee level, employee name, initial salary, and current salary. So initial salary is your joining salary, so let it be. Then promotional increase will be, let's say, any ID. So if I write on the steps, so any employee who had any promotions will get percent increase implemented on top of joining salary, right? So first, left join the promo table with employee table, right? Because employees evergreen, you will be there. All the employees are there. This is a dimension table, and promotions is also actually, yeah, I think this does not change much. So promotions can also be called dimension table itself. So you add it there. So Alice can have, let's say, multiple promotions, right? Yeah, she had two promotions. So first, what will be applied? So there's a 50,000, then 10%, and then again, the next one will be 55,000 and then 20%. Something like that. That will be applied. That will be your percent increase. And then same for all the other employees as well. So what do we do? First, you have to left join, as I mentioned. Then take the initial salary, current salary, then map again. What if somebody had seven promotions? Yeah, there are four promotions for employee number 4. So we cannot keep on doing this for 4 times. Okay, what we can do instead, okay, one other thing that can happen, let's say, since it's like 50%, 50,000 into 1.1 into 1.2 is basically is your current salary, right? So what we can do, we can actually multiply these. 10 into 20 would be 200. No, not like that. So let's say 10%, right? So we can do something like 110% into 120%. So keep it like that. And then finally we can multiply it with the initial salary. I think that is a better option. So take the percentage increment multiplied with each other in the second table and then bring that to employee level. Finally, join the second table with the first table. right? Whenever there's null, we can keep the first value, initial salary. So we do not have to do left join first. So let's do, these are the steps. Let's get going. Hopefully this is an easy one. So let's start. So with if I take ID level, yeah, employee ID level percent increase. So what I'm thinking is, again, sorry, just to explain employees and promotion. Yes, if I run. So let's say for employee ID 1, which is Alice, um, percent increase would be 50,000 cross 10% cross 20%. I mean, 50,000 cross 110% and 120%, right? So essentially what I'm thinking is let's do multiplication of both 10 and 20, like 110 and 120, and then finally get it multiplied to 50,000, right? So that's what we can do. Let's see. So with, let's say, multi as. So here, since multiplication is not an aggregated function, we have to take something like a backdoor. So we have to apply log function, and they then take sum of the log function and then further exponentiate it to get the multiplication. So there is no function that we can use automatically or readily within SQL. And also we cannot create a function like Python. So that's what we will do. So if I do select, let's say select ID comma not ID, let's say employee ID. I do not need promotion date because that's not needed. So if I do exponent of, let's say, sum of, let's say, log of, okay, 100 plus percent increase, right? As, let's say, percent increase, something like this, from promotions group by EMPID, right? How about this? Let's try this. Yeah, so employee in percentage increase. Okay, I think just round is fine. Sorry. Yeah, so this is good, but then I have to divide it by 10,000 because number of promotions. How about promotion date? Or just count star would have done as counts, let's say. Okay, so I need to divide it by 10,000 because 100 to the power 2 or 100 to the power 2. Here also 100 to the power 3. So this is 1.2, this is 1.15, this is 1.32. That's what will be multiplied. Okay. But rather than, taking, like again, dividing this by 100 to the power 2, 100 to the power 3, etc., etc., can we do something like at the starting itself when we have the percent increase, let's divide that by 100 because every percent increase will be divided by 100. That's common. And then add it to 1 rather than 100. Add it to 1 and then take that. Yeah. What if I do something like this? So let's say, um, you know, percent is increased by 100 and let's by 1 and let's take this one. Cost as decimal, let's say. Right, so that is something that I'm taking and then I'm multiplying, sorry, adding with 1. So what if I do this? What does it? Oh, okay. Now I have to do a round of, let's say, 2. How about that? No, that also it's not happening. Let's say if I do, one second, let's forget about all this. Not needed. Sorry. Let's do this. Select list is not in group by. Yeah, that's okay. 1 second. So percent increase by 100 as decimal. So if I don't need this, let's say I don't need this, right? Because that's not necessarily needed. Select star from multi at line 5. Okay. No, everything is just horrible. Okay, percent increase by 100 as decimal. Okay. What if I do this? Not happening? Okay, what about float? Some places cast function does not work. Okay, this is working. 0.1, 0.02, 0.05. 0.1, 0.2, 0.05, 0.1, etc. Okay. Okay, not bad. Then let's say if I do 1 plus this. Okay, let's try. 1.1. Okay, this is working. So let's take as, let's say, log of this, and let's take sum of this, and it happened, right? So sorry, 1, 2, 3, 4. Yeah, this is fine. Now let's take exponent of this. Let's see if this happens or not. Oh, we need, sorry. We need group by empid. Yeah, that's happening. Let's do round, comma, 2. Cool. Okay. Yeah, we're good. This is better, I believe. So percentage increase directly came. You do not need count of promotion anymore because it's directly 1.32. It's not 13200. This is much better. And then from promotions, okay, here I can do directly join with, employees. Let's say P and E on E dot ID goes to P dot employee ID, right? And what do we need? We need ID, name, okay, employee ID, a name, comma, joining salary. Oh, I need a left join because some employees might not have had any kind of promotion, so they will be skipped off if we are doing inner join. So let's do left join, right? So employee ID is fine or ID is fine, either ID. Okay. ID is fine. ID, name, joining salary. Then we have round, we have percent increase, and that's it. From employee, current salary. Oh, why don't we do something like this? Into initial salary or multiplied by initial salary, right? That's your current salary, right? EID, joining employee ID, all fine. Group by ID, name, joining salary. Yeah, we can take all this, not a problem. Okay, I can remove the CT, but let me try this first. ID in field list is ambiguous. ID is ambiguous. How? Okay. No, but should. Oh. ID shouldn't be ambiguous because it's only present in one table. But either way, okay, let me. Oh, promotions B. That's why it's ambiguous. Initial salary. Not initial salary. This is joining salary. Joining salary as initial salary. Okay. Okay, this came 50,000, 66,000, 69300. No, 300 should be the case. This is 600. This is wrong. 84,892, this is 84,700, 96250. Mine is rounded. This is not rounded, but close by, I would say. This is happening purely because of, not null. Current salary and joining salary, right? So initial salary is fine, and since there is no percentage increase, it's becoming this, but I can do a qualis. I can do comma, joining salary. So that's not the problem. This can be taken care of quite easily, but around, if I do 0, will it impact? Let's see. No, that's not a good way. So round 0 is not a good way. What if I do something like this? Nope. 2. 2 is definitely closer, but this is not working. Mhm. What if I do 1.0? Almost everything is fine. 1, 2, this one, and okay, 4 salaries are different. 55,679, 55,680. So it's close by only. Again, I think this is due to the way I have calculated it, and due to the way, let's say, this actual platform might have calculated it is a little different. That's why that this kind of like I have taken a backdoor, right? So exponent, then sum and log and all that. That's why it's coming a little different. So there might be a different way to solve this altogether. But for like before going there, I think what I need. Percent increase, this is fine. Float. Rather than round 2, what if I don't give this round? Is this better? The same. Let's say what if I don't give round any at all? What will be the change there? Okay. It's much more closer. If I don't give round, it's almost same, right? It's almost same. So qualis is fine. After that, let's say, let me give round of 2. After that, let's see. Fine. Okay, so you're understanding. Before giving qualis, if I'm giving the round, then it's not matching directly with the expected output. So again, I won't call either of the ways to be wrong necessarily because we are taking similar approaches. So here it depends on, the way we are calculating the percent increase and the way we are defining the function. Again, as I'm mentioning repeatedly, I've taken a backdoor. You can exercise in any other methodology that you find fit. I'm absolutely happy and, eager to learn that as well. But I think this is pretty, good and sophisticated solution. Given that this is a very neat solution, you don't have to write lots of lines of code. If you know these functions, of course, you need to know these functions and that trick. But otherwise, this is a good enough solution is what I feel. Let me evaluate. Answer is correct as we know that it has matched exactly. So that's all good. Let me move ahead. All right. I think we just have one problem left. Number of Grand Slam uh, tournaments won by each player. The result should include all players, even though who have never won a tournament. For such players, the count should be 0. Okay. Return the result with columns like player ID, name, and Grand Slams count. The result should be sorted by Grand Slams count in descending order. Okay. Player ID and name. Okay. small table. Championships table, however, has column name and data type. Okay. Year, view date, and article ID. What's view date? Article ID. Okay. Players and championships. Player ID and player name. Okay. Year, Wimbledon, France Open. Wait. What's view date? Um, okay. Okay, let me read again. Sorry, each of these tournaments, this is fine. Championships table, all the four tournament columns have the winner player ID. Acha, okay, I think this is wrong. View date and article ID is not correct. Correctly put out. Okay, we can, of course, let the platform owner know about this so that they can fix it. But either way, I think this is pretty understandable from the example itself. So we have player ID and player name, which is very simple. And we have here Wimbledon, France Open, US Open, Australian Open. And these are the player IDs. So three would be Federer. And all of them. Okay, fine. Can we do something like, uh, okay, so see, in this kind of problems, we will have to go ahead with join. We have to do multiple joins basically, if I'm not wrong. So we have, let's say, player ID 1. So 1 would be mapped to Wimbledon first, then France Open, US Open, Australian Open, etc., etc. And then finally, whenever there's a map, we can take a count of the same, right? So yeah, that's how it pretty much goes. So we can do something like this. So let's say we can try mapping player ID with Wimbledon first, and then we can try mapping with France Open next, and US Open, and then Australian Open, right? So something like, let's say, first one will be mapped here, right? And then maybe three will be mapped somewhere, and so on and so forth. Of course, we have to do left join. It's specifically mentioned we have to do left join. So we can do that. And then for France Open also we have to do that. US Open and Australian Open, both, all the ones. Do we need year-wise or something? We do not need, right? What's the expected output? No, we do not need year-wise. So year can be discounted here, not a big deal. What I'm thinking is I think rather than doing join in the same table, probably it'll make more sense if we do a union and then take a sum. I think that makes more sense. Hmm. Okay, so what I'll do first, I'll take join the sorry, not employee ID, player ID column with each of the tournament columns. What I'm thinking is if I do join multiple joins in the same query, Wimbledon, France, US, and Australia, then summing those up might be like counting those might be a little difficult. So that's why unioning probably is a better idea. Take the union and then finally aggregate. Right? So let me start writing the code then. So first I'll take, let's say, mapping as, let's say, select player ID, comma, Wimbledon, as, let's say, tournament from, what's the table name? This is players A, left join, championships C on A dot player ID equals to C dot Wimbledon. Right? That's it. So that's what will happen. Then what I'm thinking. So here what will happen? 1 will get mapped to 1 here. 2 and 3 and so on and so forth. Those many times that will happen. This will happen. And finally you can take a count at the end. Like by player ID, you can take overall count. Make sense? Mm-hmm. Actually, let's not do left join here. We can do left join later. Let's get the player ID first, and then we can take joins later. Then do union all. That's what I'm thinking. Basically, take the same thing rather than Wimbledon. Let's name it as FR Open. This is tournament, same thing. But not rather than this. This will be this one again. Take the same. Select player ID. US Open. Sorry, US Open. Right, as tournament, and again, and then take AU Open. Then finally, we will have player ID and player name. We can do a left join from with that. Let's do aggregation. Aggregation as select player ID, comma count of star as I don't know, grand slams count from the above table, which is mapping. Sorry, mapping. Group by player ID. Then finally, you can take select player ID, player name, comma, grand slams count, and this will be coming from P dot player ID. Grand slams count will be coming from the above table. Players P join, sorry, left join. The grand slams count can be Wallace 0 as grand slams count. Left join, aggregation A on P dot player ID and A dot player ID. So this should be the final output. Let me run the code and check. Sandbox championships, sorry. Championships C. Run code. Okay. Djokovic, Nadal, all have come properly. 1, 2, 3, 5, 4, 6, 7. No, I have to order it by. Order by Grand Slams count ESC. Right? Run code and evaluate. Hopefully things are fine. Answer is incorrect. Okay, let's see. Oh, okay. What happened? Order by Grand Slams count DESC PL at line 40. What happened? Till now it was running fine. P dot player ID, A dot player ID. Sorry, what? Okay, let me run it again. Sorry, I didn't get the. Okay, what happened? I just changed this one. Let me run again. Did something change? Okay, now let me run. Okay, everything is fine now. If I do order by, then there's a problem. Okay, should be fine now. Let me evaluate. Correct. Okay. There might be might have been a syntax mistake, but otherwise, I think this makes sense. Here, you have to do mapping, at union level so that you can take the count properly. You could have done, we could have done, let's say, clear ID and then mapped with each of the four columns in the same join itself. Like we would have had to join maybe four times. Here we have done union and join four times. So, that also would have been a possibility, but the way I'm thinking it, counting at the end might become a problem in that case. Here, since you have to count and that too at a player ID level, it makes more sense if you are taking it one column so that we are able to aggregate at the end of the day. So to me, this makes more sense. But again, happy to hear your answer as well. Feel free to comment or let me know any other solutions that you have thought of. Okay, that was all. This was the end of the overall Namaste SQL free problems. I definitely have to give a thumbs up to Ankit Bansal. This was definitely very fun for me and challenging at the same time for me to solve all these problems. Definitely interesting, intriguing, and many things to know. Different kinds of problems that I've seen in other platforms. This was a unique one. Okay, so that was all for today and happy practicing. Also, I would be so very soon coming up with multiple series to make you understand machine learning in a different lens, to be able to relate to the business part of the same as well. So stay tuned for that. All right, take care, and I'll meet you in the next one.